I'm
I'm
so
just
sorry.
gonna need that back sometime before we do that.
Okay.
Also, I got a really funny because I really think it's right.
So here's like a couple of big ideas that you have to have at this point, okay? And how all of these threads kind of fit together.
I only have small ideas.
Well, we need big ideas. So when you have a spontaneous reaction, here's the first thing I want to dispel. Just because a reaction is spontaneous, that does not mean that it happens rapidly. All it means is that you don't have to have a power source to make it happen. Now, that doesn't mean you don't have to have something to start it, which is called activation energy, which we'll get into after spring break. Like hydrogen and oxygen will readily combine to produce water. Now, conveniently, that doesn't happen like, oh, all you have to do is put hydrogen and oxygen together and you get an explosion, okay? Which would be bad, right? It's like, oh, I got a tank of hydrogen back there. There's a lot of oxygen in the room. Every time I open up the hydrogen tank, there's a leak. Oh, there's an explosion.
That'd be pretty sick.
That
Unless you
would-
know when it's leaking.
It's true. Like, hey, Burkamp, your room exploded. Oh, my bad. So, now, you throw a match, hey, then that reaction happens. So that, just because it's spontaneous doesn't mean that you don't have to have, like, get it started. But once you get it started, it continues to go. Okay. So on 71, and this is kind of the manifestation of this idea. There's three criteria that have to be met for a reaction to be spontaneous. First off, what's the sign of E naught going to be? Positive value, okay? So you're gonna have a positive E naught value. Then when you look at delta G naught, which is Gibbs free energy, which is negative NF E naught, this is the next piece of the puzzle. So if you have a positive E naught value multiplied by Faraday's constant, and then a negative N, what's going to be the sign of delta G naught? It's going to be a negative number. Okay, so here's the first two criteria to see a spontaneous reaction. Positive E naught and a negative delta G naught value. Now, here's your third criteria, is that you need to calculate K. And K is 10 to the, what is it, E naught value times N over, I don't even know, over Faraday's constant, if I remember right. No, 0.0592, my bad. That was my stomach. I really didn't have time to eat much lunch. Yeah, sorry, it happens. It's 0.0592 times,
Wait.
no, it's E naught. I had it right the first time.
Yeah.
It's E naught times N divided by 0.0592. So here's the third piece of the puzzle, is that if it's a spontaneous reaction and you have E naught, a positive E naught value, that means K is going to be big, okay? So all three of these fit together. Positive E naught, negative delta G, a big value for K. So on 71, two of those, B and D, should be spontaneous reactions, okay? Sean, make sure that you have a balanced with charges reaction for B and D. B is simple, D is a little bit more complex, okay? So on D, if you kind of have to sort out the lingo, because it says an acidified solution of FeSO4 is exposed to air. And in the end, I put a little hint that says oxygen. So you have Fe2 plus, right? It's an acidified solution, so what does that also mean is present? I'm going to have some hydronium ions, okay? Now, in the air, you basically have two choices. You have nitrogen or you have oxygen. Have we ever talked about anything reacting with nitrogen? No. Okay, nitrogen is there. It's cool that nitrogen doesn't react with a lot of things, okay? If nitrogen reacted with a lot of things, our lives would be different, okay? if nitrogen reacted the way oxygen did, if you started a fire, you would never get it shut down because of the fact that most of our atmosphere is made up of nitrogen. So nitrogen is there, but it's pretty much inert. It likes to hang out with the other nitrogen atoms, but they chill out. Oxygen, on the other hand, really does want to react. So, the oxygen. Now, remember when you have Fe2 plus, Fe2 plus can do one of two things. It can turn into Fe3 plus, and it can turn into elemental iron. In this situation, what's it going to turn into? Yeah, you're going to turn into Fe3 plus. Then you can figure out your half reactions from there. So, on that one, on 71D, your K value should be like something times 10 to the 31st, okay? Really big number. Your E naught value should be around 0.5, okay? Or on 71D. And if you balance it correctly, you should have, listen to me, Gapshon, on 71D, you should have 2 waters in that balanced equation.
Oh my God, I don't think that. I divided it by 4. I don't know why I thought that was very responsible.
Okay.
God, I'm so silly.
Yeah, I can put them all.
I amazed myself.
On 73, with that one, your K value should be around something times 10 to the 10th. Huh? So on 73, your K value, around 10 to the 10th. Now, let's talk about 75.
Please.
So on 75, you're asked to find a KSP value. What do you know about KSP values? Pretty
Small.
big, pretty small. Pretty small. So when you take 10 to the E naught times N divided by 0.0592, what has to be the sign of your E naught value to produce a small value for K?
Negative.
Negative. This is the big picture. Oh, K values are small because these things don't separate. They don't ionize. They stay clumpy. Okay? That's why they don't ionize very much, because that's the only way you can get a small K value. So if you look at what you have cadmium sulfide plus 2 electrons turning into elemental cadmium plus a sulfide ion. Bless you.
Thank you.
And then you have CD2 plus 2 electrons turning into elemental cadmium. And that one is negative 1.21 volts. And the negative 1.402 volts. Now, look, just think this through. Okay? There's a couple of ways you can view this. One, you have 2 reduction reactions. So what do you know about one of them?
They gotta be flipped.
One's got to be flipped. Okay? Question being is which one do you flip? So one option is if you're a math nerd and you go, wow, I want a negative value for my E naught because I want a small K value, which leads you to flipping which one? The first one or the second one?
The second one.
The second one. So mathematically, you choose the second one. Okay, cool. Now, the other way that you can think this through is more of a chemical perspective, because you want to find the KSP for cadmium sulfide. Well, how do you write the ionization equation for cadmium sulfide? What's it turn into? CD2 plus and sulfur 2 minus. So right away, where does cadmium sulfide have to exist? On the reactant side or on the product side? On the reactant side. So if you flip the first one, you're screwed right from the beginning, because you put cadmium sulfide, which is going to be a product, on the reactant side. So if you want to look at it from a chemistry perspective, you want to look at it from a math perspective, I don't care. But here's the beauty of this, is that when you flip this one, when you flip this bottom one, and that becomes cadmium turning into CD2 plus 2 electrons, there's a couple of magical things, really not magical, but, so number one, you're going to cancel out your electrons. Okay, those go away. That's kind of what you want to have happen. And conveniently, they're both 2. Cool. Okay? Then, those are going to go away. I'm going to have cadmium sulfide as my reactant. Then, I'm going to have my sulfide as a product. I'm going to have my cadmium ions as a product. Winner, winner, chicken dinner. Okay? So, your KSP value on 75, oddly enough, should be a really small number, like something times 10 to the negative 28th.
Cool.
So the KSP value is the same as the K value that you find?
Yes, all we're doing by putting
Okay.
KSP on the end is we're specifying which K it is. Just like you could put
Did not do that.
KA, that just tells me, oh, that's relating to acids. If you put KB, that's relating to bases. Okay, all the subscript does is tell you which type of K you're looking at.
Makes sense.
Okay? Are we good?
Yeah,
The
that's,
first 75?
yeah,
That made sense.
yes.
That speaks to you.
That made a lot of sense.
Okay.
83 does not speak to me. I was like,
Usually-
oh, I
Now-
find out it's 83.
Anything after this?
Oh,
Let's talk.
I'm not gonna lie.
One sheet.
Hot take.
I think we should
That's
grab the
Everything
book.
after 83 makes
I think we
Okay.
should grab the book question.
So,
Yeah.
gosh, my shoulder. So let's talk about 83. So right away you're talking, you see the word electrolysis. What does that mean? Is it spontaneous or not spontaneous?
Not spontaneous.
You've got to put energy into it. Okay? This is not going to happen. You're still going to have a cathode, you're still going to have an anode. You're still going to have a voltmeter, current's still going to flow. What's going to happen at the cathode? Still, reduction or oxidation.
Red cat.
Red cap. It's oxidation is still going to happen at the anode. Okay? Nothing has changed. That's it. So, you have a molten metal chloride. So, in here, in this vat that you've heated up, what do you have available in here?
Some things.
But what's the charge on that metal ion?
+3.
Plus 3. Because you're told that it's, what is it, MCO3? Okay? So whatever this metal is has a charge of 3 plus. If it had been MCl2, it would have a charge of 2 plus. If it was MCl, it would have a charge of 1 plus. So all you know is that it has a charge of 3 plus. That's going to be important. And then you also have chloride. So you do not have the elemental form of the metal. You have the ionic form of the metal. Okay? You got to get that straight. This is not a metal. This is the ion of the metal. Now, what that means is how many electrons is that ion going to take in? 3, because it's going to become the elemental form of the metal. Okay, it's not going to go to M2 plus, it's not going to go to M1 plus, it's going to go all the way to the metallic form of the substance. So, you're also told that you're going to apply a current of 6.5 amps. So, when you have 6.5 amps, that is your current. Okay, that's your value. You have to understand the lingo. Oh, that's my current, that's I. And that equals to what? What's the other thing that equals to? Coulombs per. So that what that means is that we're forcing through 6.5 coulombs per second. That's the other part of what this means, right? Now, you're gonna run this for 1,397 seconds. So part of this is gonna be, where do you even start? I'd start with the 1,397 seconds, okay? And the reason I'm gonna start with that is because I know this is coulombs per second. Okay, cool. That's 6.5 coulombs per 1 second. Nice. Now, if I stop right now, if I do nothing else, what do I have? I have coulombs. Do I want coulombs? Coulombs gets me nowhere. Okay, it's a cool number, but it just doesn't get me anywhere. So, at the end of the day, what are you trying? How are you going to identify this metal? What do you need? I need molar mass, which is what? Grams per mole of the metal, right? So I've got the mass of the metal. That's cool. What I don't have is how many moles there is. So now I'm stuck in Coulomb. Big trouble with China. Is there a conversion that relates coulombs and moles? The electron one. Okay, you gotta get a little bit more specific.
But I put in my case.
How about Faraday's constant?
What?
What? Because what the unit?
You're so tired of us, I'm so sorry.
Oh, you have no idea how I'm not tired. So,
Aw, thanks.
could I take advantage of the fact that Faraday's constant is 96,500 coulombs per 1 mole? Could I go somewhere with that?
Yes.
Ooh, am I gonna put the coulombs on top, or am I gonna put the coulombs down below? Whoa, down below, why?
Cancel.
Because if I put them on top, I'm gonna get coulombs squared, which is a train wreck, okay? So I'm gonna put the 96,500 coulombs per 1 mole of electrons. If I stop right now, what do I have? Do I need moles of electrons?
No.
I got moles, but it's the wrong type of moles. What do I need? Moles of the...
Metal.
So how can I take this and get moles of the metal?
Electrons for one.
Oh, there's 3 moles of electrons.
Oh, because it's 3 plus 5.
Ooh.
Yes.
Okay, I was doing it right.
Okay.
For every 1 mole of M. Do I need to do anything else? No? In this conversion.
Okay, no.
In this conversion.
No.
Am I good?
You're good.
Because what's this going to get me?
Your moles of metal.
Moles of the metal. Right? Once I get that, then what can I do?
Divide your grams by moles.
I can take my grams and divide it by...
Moles.
Now, if you wanted to get fancy, you could put the grams up there on the end if you wanted to. Okay? But I wouldn't. I just put it down here and then you don't have, then you know you're gonna get it right. So, your metal should end in IUM. Boy, this can't be silver.
Well, I know it's not silver, I know what it is.
I don't-
Okay. Well, I'm just telling you, I'm trying
feels
to
like
be
something where
helpful.
they're-
I'm trying to be part of the solution, okay? So to speak. I promise you on the test, there's gonna be a question like 83.
I'm okay with that.
I'm telling you straight up, there's gonna be one, so it is like, oh man, Burkamp didn't warn us about this
Yes,
one.
but Bert, what happened to the last question you warned us about? Like the oxygen and hydrogen limiting reactant? We all missed that one.
Oh my God.
But I told you it was gonna be on the test. You didn't all miss it. The vast majority of you missed it.
Look on your calculator.
Okay, on the 2 problems out of the textbook, okay? So, on 2091, this is what I would do.
Okay, we're good.
On part A on 91, start with the 2 days, okay? Start your conversion with the 2 days. On B start with the 0.250 moles of chromium. These are just basically long stoichiometric problems. So on 91A, the mass of the chromium should be around 240.
Okay.
Okay? Your amps on 91B would not make a good GPA.
Uh-oh.
Okay.
No, sorry, that's, I was just imagining if that was my GPA.
Okay? Not completely horrible, but certainly not all that good. On 92, the mass on 92A should be a little bit less than your answer to 91A.
Okay. 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 I'm okay with that.
About 10-ish,
Okay.
okay? About 10-ish. On 92B, in minutes, listen to me very carefully, in minutes, it should be about 1,000.
Okay. I'm cool.
Okay? So 91A, around 240, 91B, horrible GPA. 92A, around 220, 92B, around 1,000.
I call this a success.
Are we good?
I think we're good.
Once, twice, sold?
So.
Okay. Kevin, stop the camera, please.